Hello, everybody. My name is Paul Gebheim. I'm from the Forecast Foundation. Today, I wanted to talk to you about a couple of things. Big one is new prediction market that we have, a new prediction market platform that we have. This is in collaboration with Chainlink. And that is called Augur Turbo. And we'll also speak a little bit about something that we're calling multi-stage oracles. So to start, I'll just give you the really quick TLDR on Augur. Augur is a prediction market platform that is based on Ethereum. It's been around for approximately forever. Existed as an idea in 2014. In 2016, there was a token, and the first major version of the product was released in 2018. This is Augur V1. So in Augur V1, we built a product which was a prediction market platform. Prediction markets are a generalized financial market. So you can think about them as a tool for predicting what any event will be, also known as a betting market. So we built this out with fully on-chain trading and full on-chain order books. So this looked like a normal trading site where you would have outcomes on particular events, and you would have an order book and you could select your pricing on those. The markets that were created for Augur V1 were fully custom. This meant that anybody in the world could type a question about anything they wanted and turn that into a financial market. And the markets were resolved by our first version of the Auger Oracle. And I'll talk more about what that is later. What we found was that we made some mistakes. It was the first version of a product and we needed to improve it. So we worked for the next couple of years and we built Augur V2. Augur V2 changed a couple of things. First, we did off-chain order books, which meant that the way that people would see what orders were available to take on the market were distributed off-chain using 0x, but the actual trades still happened on-chain. We still have fully custom markets, but we also added in this concept of market templates. A market template was a way for there to be a general format for a type of market. So for instance, for a political market, it might be, does candidate A or candidate B win an election on this date? And then there was rules to specify what win means. And we also tweaked the Augur Oracle. There was a couple of issues that we found with the original Augur Oracle that we tweaked in Augur V2, specifically around this concept of a market being able to be invalid, meaning that based upon the rules of how that market was written, there was no proper way to resolve it. So we built both those things, and something happened in 2020, which you are all familiar with, which is DeFi. So when we launched Augur V2 in 2020, what happened was gas prices went through the roof. Everything was at 80, 100, 200 gwei for days as people were doing as trading. And we realized that one of the core premises of how Augur worked was that the on-chain trading aspect of it was just too slow and order books weren't going to work for the current market. So we zoomed out a little bit and we decided to go after a new type of product and build it in a different way. And this one we call Turbo. So Turbo is AMM based, uses balancer pools. It's on Polygon. It has user-created markets, meaning the users get to select which markets are actually have trading activity on them. But the data for that is placed from an API on-chain by Chainlink. And markets are also resolved with API data that's placed on-chain via Chainlink. And so you might ask, where is the Augur Oracle? And this is something that we've been asked a number of times. So I'm going to go into how we think about this problem. So the basic premise of Augur Turbo is it should be fast. The main problem that we identified with Augur V1 and V2 is that they're just too slow. So in Augur V1, you have everything created manually. There's 24 to 48 hours for a market to resolve. So say once the sports game ends, or once let's say there's a market about what will the price of cotton be in Guam or something. Once that event is known, it would take between 24 hours and 8 weeks in order for the answer to be correctly put on chain and people be able to get their money out of that event. And that was just too slow. So with Turbo, what we decided to do was to kind of switch this up. What we want to do is just have markets just exist, meaning that there's certain data that's known on chain, which can be formed into a market, and that just to be there. We want markets to resolve automatically. We don't want a human to have to be involved in every step of that. For Augur V1, there's some benefits, which is that you can technically create a market on anything. For Augur Turbo, we're limiting that and saying we can only show markets that there's good data on chain for. So let's talk a little bit about the Augur Oracle. So the Augur Oracle is a very complex beast, but it exists in two basic parts. One of those parts is simple, one of those parts is complicated. So the first part of the Augur Oracle is called the initial report. This is the answer that is initially said that a market outcome is. So what will the result of a presidential election be? You know, it might just say Joe Biden. That's just what the answer is, and that is put on chain. The second part is the disputing process. So the disputing process happens if something goes wrong. So with this insight, we can look at what the difference between the reporting and the disputing process is. So in the reporting, in the initial report, in V1 and V2, the initial report is done by either the market creator, the person that typed in those market details, or it's done by somebody that they delegated. And that data is currently in V1 and V2, you just literally go to a web interface and you put that data in, and then you do a transaction on chain with it. In Augur Turbo, that data, the initial report data, is determined from an API and is put on chain via a Chainlink Oracle. And then we'll look at the disputing process. So the disputing process is what happens if something goes wrong. So if we can look at the case of the presidential election this last year. There was a dispute as to whether Donald Trump won or whether Joe Biden won. That dispute was something that wasn't related to a data source, wasn't related to a contract, wasn't related to how a node operated. It was just an actual dispute in the real world about what happened. So for Augur V1 and V2, the mitigating factor for that would be rep holders. They go through a set of dispute phases that let us determine who the winner is. And this is economically secure in some ways that we can read about in the white paper if you're interested in that. However, for Augur Turbo, we're starting out because we're going for fast, fast, fast. That doesn't exist. So right now, we're only resolving markets, or the system only resolves markets where data can be just placed on chain. The thing about initial reports is it's very simple, smiley faces. The problem with disputing is that it's very slow and complicated. So you kind of want to not do disputing unless you really have to. Again, Augur Turbo is fast. Ideally, all markets will be resolved correctly via the initial report. So for Turbo, we can only support markets where there's good API sources for them. And this is where we ask the question, but what if something goes wrong? All sorts of things could go wrong here. The API provider could have, just had wrong data for some reason. Somebody maybe the Chainlink node, somebody hacks into it and maliciously puts wrong data on chain in order for them to win their bet. The one that's most interesting here, though, is that the real world just actually has a dispute about what's happening. So all of those things can occur. So in those cases, what we want to do is consult the Oracle. So this is something that we haven't built yet, but to answer a lot of questions about Turbo, when we released Turbo, we said, hey, we're going to be using Chainlink data. And people said, wait, aren't you guys competitors? Isn't Augur supposed to solve the Oracle problem? Well, the answer is that the Oracle problem is not that simple. So this is when we're going to talk about this thing that I'm coining right now is multi-stage Oracle design. So what we're talking about for Augur Turbo is building out this multi-stage Oracle design where we start with using an off-chain Oracle system. This is the initial report. With the initial report, what you're looking at is the data to be reported by Chainlink or any other system, and that to be placed on chain. Sorry, let's see if this goes. And then by default, this answer is accepted. It's just that is the result of the market, unless somebody disputes it, unless something happens where somebody says, wait, that does not look right to me. If that happens, we're going to move on to our next phase, which we are calling fast disputing. And I've got these three little letters next to fast disputing called KBC. I'll describe what that is in 1 second too. But what happens with fast disputing is we are just going to vote on what the correct outcome is. We want this to happen in a very short time window. This can happen on layer 2. When this voting happens, people basically take rep or whichever token, but in this case, it will be rep that they want to use to vote, and they say, hey, this is the outcome that I think won. This is technically something called a Keynesian beauty contest. What it is it has everybody vote on the outcome that they think everybody else will vote on being correct. However, the idea here is that this is a middle phase where we're able to use it to determine if there's enough money at stake to then go into the long, slow disputing. So what this means is that these first 2 phases, the initial report may take 1 to 2 hours to get on chain. The fast disputing phase may take 1 to 2 hours in order to determine how much money is at stake. And if it reaches a certain threshold, it will move on to the next stage. If it doesn't reach a certain threshold of value, it will stay in the fast disputing phase. And then we're going to talk about the last one, which is Augur forking. And then we move on to the Augur forking oracle. And this is exactly what we had originally. This will happen on layer 1. So we're talking about moving those results back from layer 2 over to layer 1, including all of the money, and saying, okay, there's $4 million available on this market. Now we are going to go through the slower Augur Oracle process to determine what happens. People use their rep in this world to also stake on an outcome. But if it reaches the forking threshold, which is currently 12.5% of rep market cap, then that market will go to forking. What happens with forking is that everybody is able to choose which universe they want to live in. So if forking happens, you end up in a case where we actually create 2 worlds, one where Joe Biden wins, one where Donald Trump wins, and people decide where they want to move their rep to. By moving their rep to either of those universes, they are no longer able to keep their rep in the initial universe. And if nobody uses the universe that they're in, their money will become worthless. So we can read more about the disputing system here. But the important part of the disputing system is that we are able to actually take advantage of what Chainlink does the best in this case, which is do relationships with people in order to gather a lot of off-chain data, make sure that that's put on-chain in formats that's readable and usable by smart contracts, and get that data like into the ecosystem. We're then able to take advantage of the fact that the data is in the ecosystem in order to build markets that just exist because the data is there, markets that resolve very fast in the happy path case, but that also have a good mechanism for falling back if the real world changes. So this is something that you don't see discussed a lot in the Oracle space, but trying to build something which both matches the UX desires of actual humans, which is that things happen fast and reliably, but gives fallback cases a way to properly handle more complex cases. So we think this is a pretty novel design. It allows the Chainlink to do what they do best. It allows us to do what we do best, but it also introduces a new concept, which is this forking as something that just can kind of exist as a part of a system, and hopefully it will never be used. I like to call this the threat of forking. So what we want to do is we have this Augur disputing system sitting out there in the corner, just waiting on something to go wrong. If somebody lies about a value, then people can actually dispute that, bring it through fast disputing and get it to Augur disputing, and we can properly resolve the market. So that's what we're working on right now. The next phase of the plan is working on getting more markets shown in the UI based upon data that's on chain, and then we will be working as the amount of money in the system increases, as OI increases, work on adding this to the Augur Turbo system, which we've been working on with Chainlink. So thank you very much, and I'll look forward to reading your questions.
All right, thank you, Paul, for the keynote. That was awesome. It's great to see projects like Chainlink and Augur working together.